Hi class, welcome back for another lesson. Today, today's lesson we are going to focus on the action of tree. Look at the next concept here, action of tree coplanar forces. Okay, what is the meaning of coplanar? Coplanar means all the forces are in the same plane on a rigid body. Okay, so here I have a rigid body. Okay, it is being acted upon by three forces, which is F1, F2 and also F3. Okay, so when it's acted upon by these three forces, if this rigid body is in equilibrium, if this rigid body is in equilibrium, which is a static equilibrium, then what happens? That means all the three forces, this is a concept, yeah, all the three forces must pass through a common point, must pass through a common point. So when you given a question, you first find the three forces, and then when you have found the three forces, you realize that they must pass through a common point. So when you're given this kind of forces here, you have to extend the forces, and then here you extend, and then here you extend, then you'll notice that O is a common point. So O is a common point. And when O is a common point and all the three forces pass through a common point, then we can say that the rigid body is in equilibrium. This kind of questions, class, I'm going to show you an example. Is a past year's question. The figure below shows a uniform rod of weight W placed on a smooth hemisphere, smooth with one end of the rod in contact with the floor. Okay, which of the following figure shows the correct direction of the forces acting on the rod? Okay, now this kind of question, what shall we do? We apply the first concept, okay, which is if it is a smooth surface, then the normal reaction will be perpendicular to the surface. Okay, so if you see in this diagram, this is the surface. So this is the normal reaction. So this is the surface. Okay, so the normal reaction, this one is not perpendicular. So this one is wrong. So this is the surface. Okay, so the normal reaction should be perpendicular in this direction. So this is wrong. So the answer is either is C or D. Okay, alright, D is definitely is wrong. The next concept will be all three forces must pass through a common point. So if I draw this, okay, you see this one is in this direction, this one is in direction, this one is in this direction, so they don't pass through a common point. So even if I put this one is in this direction, this one is in this direction, but this one is not passing through a common point. But if I put this one is in this direction, this one is in this direction, and then the W pass through a common point. So the answer will be C. Okay, if I do this, this one will be in this direction, this one will be in this direction, and this one will be in this direction, which is this one. Okay, so therefore, but this one is wrong because of the direction of the normal reaction. Okay, alright, so the answer will be C. based on these two concepts.
Concept number 2. This concept, now we know the concept. Let's learn how to apply.
This example class is one of your example, which is 7.6 from your Oxford Fajar book. Okay, now let's see how we can apply the concept of equilibrium of a rigid body in samples of questions. So let's see the first one, a ladder. We have a ladder. Okay, a ladder. I'm going to draw here a ladder. Okay, which has a length of 5 meter. The ladder is length of 5 meter and a weight of 100 Newton. What weight? Weight of 100 Newton. Okay, and the word said leans. Okay, weight is 100 Newton. Leans at an angle of 30 against a smooth wall. Against a smooth wall. So it leans at an angle of 30. There's a smooth wall here. Okay, this is 30 degrees and this wall is a smooth wall. Okay, the lower end of the ladder is on a rough floor. The lower end of the ladder is on a rough floor. Okay, so that means this one is on a rough floor. The center of mass of the ladder is 2 meters from the lower end. So the center of the mass is somewhere around here. Okay, this is cm, which is 2 meters. From here to here is 2 meters. Okay, from the lower end. Find the force on the lower end. They ask us to find the force here and the upper end of the ladder. Okay, now what's the first thing to do is to apply the concept in this example. What is the first concept we have to do is we have to draw the forces. Okay, so it's all about the forces class, so we draw the forces. Now the first force we see is the weight of 100 Newton. So there is a force of weight of the ladder. Okay, the weight of the ladder, which is 100 Newton. So if I want to draw the weight of 100 Newton in this diagram, the first thing I have to apply is the first concept, which is the A. The weight of the body okay, acts vertically downward through the center of gravity. Okay, so we must find now where is the center of gravity. And the second concept is, we know cm is equals to cg for small object. Center of mass, okay, is equals to center of gravity for small object, where the g is the same. So here it says this is cm, and then therefore this also must be cg because it's a small object and the center and the gravity is the same. Acceleration due to gravity is the same. So here that means this is the weight W. Okay, alright. So weight of the body acts vertically downward through the center of gravity. So I apply that concept. Okay, then number 2, what shall we do? The next one. The next one, we know this is a smooth wall, correct? So the concept says, number 2, I'm going to write here B. Yeah? When a rod rests on a smooth surface, okay, or support, okay, the normal reaction which is the R is perpendicular to the rod. Okay, so here is a smooth wall, so there is a force there which is a normal reaction force. This is what force? This is weight. Okay, this is what force? This is a normal reaction force. Okay, so the normal reaction force is perpendicular to the rod. Okay, so if I draw, it will be in this direction, which I'm going to label it as P, exactly like the book. Okay, all right, so that is number 2. Number 3, I have to remember what am I doing? I'm drawing the 3 coplanar forces. Okay, I'm drawing the 3 coplanar forces. So this is the first force, this is the second force. Now the third force is, this is a rough flow, so the normal reaction will not be a straight based on this concept. So the normal reaction definitely will not be a straight in a vertical axis. Okay, so what shall I do? How shall I find out? I use the concept is all 3 forces must pass through a common point. Okay, so all 3 forces must pass through a common point. Okay, so I draw from here this point here, so I get my Q. Okay, because why? They all must pass through a common point. Okay, all, I'm going to write down here, all 3 forces must pass through a common point. So this is the common point. Okay, so I get my Q. Alright, so I got all the 3 forces. I've already applied and draw into the diagram. So now it is, I'm going to apply the condition of the concept of the condition of the equilibrium of rigid body. Okay, so what is the first condition? I apply the first condition. No resultant force on the body. Okay, so here before I do that, okay, let's see what happens here. Now if you look at this diagram, this one is vertical, so no need to resolve. Weight is vertical, no need to resolve. This one is horizontal, no need to resolve, but Q need to be resolved. Okay, because it's angle theta to the horizontal. So what shall we do? We resolve this R, I'm going to put here Ry, and I'm going to put here Rx. So what do? I actually resolve Q. This is Q, right? This is Q. So I resolve it to Ry, I resolve it to Rx. Okay? Alright. Now I apply the first condition. Now what is the first condition? The first condition says no resultant force acts on the body. Okay, so I do what? Whatever left is equals to right. So this force is equals to this force. So I can say number 1, P is equals to X. P is equals to what? P is equals to X, Rx. I'm going to just put P equals to Rx. Okay, I simply label that Rx class, or Ry. You can label it as Y and X also can. You can label it as Qx and Qy also can. Okay, so I purposely put it Ry and Rx. So P is equals to Rx. Okay, then the vertical forces are the same. Okay, so we look at all those vertical forces. This is Ry, this is Ry, this is W. Anything else? Nothing. So I can say Ry is equals to W. So that means Ry is equals to W is 100 Newton. So Ry is also equals to 100 Newton. Okay, so this is number 1. This is number 2. Okay, next what I do is I apply the second condition. Okay, this one first condition is what? No resultant forces. Okay, next I apply is the second condition. Apply the condition number 2. Okay, alright. So what is the condition number 2? Sum of clockwise moment is equals to sum of anti-clockwise moment. Okay, so what is my first step I need to do? I need to find a moment where I can start. So I take moment at this point. I'm going to call this point A. So I'm going to take moment at A. So I'm going to take moment here. So when I take the moment here, I no more interested with Q, yeah? Because Q already resolved to Ry, Rx. When you consider Ry, Rx in this expression here, you don't look at Q anymore, okay? Alright, for the solution. But we can find Q later by solving Ry and Rx. Okay, so now I'm going to take moment in this particular point. So all the forces in this particular point, I will not put it into the expression because the distance is 0. Okay, so when I take here, it's completely only this force and this force only is involved. Now, why again I took moment here? Why I never take moment here? Why I never take here? Because if I take the moment here, I won't know what is Rx. You see? So that will complicate my solution. So I take whichever that is easy. So I try to shut off this. I take moment here. Okay, not shut off. I take moment here. So when I take moment here, what you can see is that I have two forces. So this is the forces, this is the direction of the forces. So if the thing is rotating, it will move in this direction, and this one will move in this direction. So the clockwise will be the weight. Okay, clockwise will be the what? Will be the weight here. So W, the force times the distance. So what will be the distance? Okay, the distance will be this and this. Okay, alright, so we don't know the distance for this. We can separately solve them here. Okay, this is L. Okay, this is L. Sorry, this is L, which is already given is 5 meter. This is 30 degrees. From here to here is 2 meter. Correct? So if I want to find here to here, so this one will be 5 sine 30. Correct? From here to here. Okay? Alright, so here will be what? Here will be 5 cos 30. But if I take here, this triangle, the small triangle here, this one will be 30 degrees. So this one will be 2 cos 30. This one will be 2 sine 30. So now I want is this small portion here, the length here, which is perpendicular. Length which is perpendicular. So that will be W times width 2 sine 30 equals to. Okay, equals to. So I take moment here, right? I take moment here. So the next force is this one. This one is anti-clockwise. So this is P. The force is P. P times width. Okay, P times width, the distance that is perpendicular to the area where it is take moment, to the axis where it's take moment, not area, to the axis. So it will be this and this, perpendicular. So this one is same as this, from here to here, correct? So what will that be? That will be 5 cos 30. So P times with 5 cos 30. Okay, so you solve it. This is 100. 2 sin 30. P 5 cos 30. So I think you can find your P. 100 times 2 times sin 30 divided by 5 cos 30, which will be 23.1 Newton. P is 23.1 Newton. Okay, so this is equation. I'm going to just put this one equation number 3 from this. This one is from the condition 1. This one is from the condition 2. Okay, we already got P is 23.1. Okay, so I'm going to put here, this is P is what? 23.1 Newton. I'm going to just put like this. Okay, now if I know P is 23.1, P is equals to Rx. So Rx is also 23.1. This Rx is also what? 23.1 Newton. Okay, now Ry is equals to W, so Ry is 100. Okay, alright. So now we look at the question there. Find the forces on the lower end. Find the forces on the lower end, that means they want us to find is Q. So they want us to find here Q. So if I write here Rx, Ry, here is Q. Correct? I separate this. So Rx is 23.1 Newton. Ry is 100 Newton. So you use your theorem Pythagoras. You get your answer is 103 Newton. Q is what? 103 Newton. So you get Q is 103 Newton. Okay, then we can also find the angle here, where tangent theta is equals to 100 divided by 23.1 Newton. So how much you get? I get 77. Theta is 77 Newton. So theta is 77 Newton. So my theta here from this to the horizontal is 77 Newton. And then they ask you find the force. You already found Q. Now on the upper end they want P, which is 23.1 Newton. Q is how much? 103 Newton. Okay, with at angle 77 from horizontal. And that's it. We have solved the question. Condition for equilibrium of a rigid body. So you know the condition of the equilibrium of rigid body is no resultant force and no resultant torque. No resultant force acts on the body and no resultant torque acts on the body. Okay, the next question. The figure below shows a 20 kg mass hanging at the end of a horizontal beam. That means this one is a mass of 20 kg hanging at the end of a horizontal beam. So this is a beam. Okay, this is a beam. The beam of length L a negligible mass that is hinged. That means the mass, we are not bothered about the mass of the beam, is hinged. Hinge means attached on the wall at a point A. That means it's talking about this. This beam is attached to the wall at point A. A cable of an angle of 30 degrees to the horizontal line is used to support the load. So this is the cable. Now it asks us to calculate the tension in the cable. So what is the first thing to do is to draw the forces. Okay, so first thing we know this is W. Okay, it's the W. Alright, then we have tension T. Okay, so this is hinged on the wall at point A. Now they never talked about the wall, you know, they never say it's smooth or it's rough. So what I'm going to do is that if this is the W, okay, if this is the weight of the beam, which we are not going to consider because they say is the word is negligible. But why am I drawing is because I want to get the common point. Okay, so I'm going to draw here and label it as R. Okay, all right, then we remove it because they told us it's negligible mass. Okay, all right, so I already draw the three coplanar forces, the T, the R and the W. Okay, so next what I do, I resolve. This one is in the vertical axis, no need to resolve. This one is in the T, you need to resolve. So this one will become T sine 30 and here will become T cos 30. Okay, then here I solve here will become Ry and here become Rx. Okay, then what shall I do? The first one, I apply the first condition. What is the first condition of equilibrium of rigid body? Is no resultant force. Okay, no resultant force. Alright, so no resultant force. Okay, so what is no resultant force? We apply the condition. Okay, now we don't bother about this R and the T once we already resolve. So what we look is we look at this force, T sine theta, T cos theta, Rx, Ry and W. Okay, so from that whichever upward is equals to downward. So I can get two equations from that. Ry plus T sine 30 is equals to W, number one. Then whatever left is equals to right, so I can say T cos 30 is equals to Rx, number 2. Okay, alright. So then what I do, I apply the second condition, which is no resultant torque, or moment of forces is equals to 0. Sum of moment of forces is equals to 0. Okay, which is what? Sum of clockwise moment is equals to sum of anti-clockwise moment. Okay, let us pick a moment. Let's pick a point. Okay, so I'm going to take point is I'm going to take this point. Okay, I'm going to take this point. Okay, because I don't know Ry, I don't know Rx, so I'm going to take this point. So take moment at, so I'm going to call this as A. Oh, they already put it A. Take moment at A. Okay, so once I take moment at A, okay, so I take moment at A, so no need to involve Ry, Rx. Okay, so what happened? There are two forces here, T sine 30 and W. So this one will be in this direction, this one will be in this direction. Okay, T cos 30 we don't consider in the take moment. Why? Because T cos 30 is parallel to R. Okay, T cos 30 is what? Is parallel to R. Okay, so remember that torque is what? F must be perpendicular to R. So this one is T cos 30 and this one is R. So it's parallel. So we no need to consider T cos 30. Okay, so we take T sin 30 and we take W. Okay, so who is clockwise? W. Okay, so W, take moment at A, W times with, okay, we want to know the R. So W times with this R. Okay, so this one is L, because if I draw with the blue pen, with the blue highlighter, okay, take moment here, right? So this one perpendicular the R, so it will be L. So W times with L equals to anti-clockwise. Anti-clockwise is in this direction, so it will be T sin 30 perpendicular is also L. So T sin 30 is L. Okay, so here it says W is equals to T sin 30. So W is 20 times 9.81 equals to T sin 30. So what is my answer? So let's solve this together. Wait, yeah. So I get my answer is 392. So T is 392 Newton. Okay, so they ask us to calculate the tension in the cable. The answer is what? 392 Newton. Okay, now they ask us to determine the reaction on the beam by the wall. So they want us to find R. So we need to find Ry and Rx. Okay, so now when T is 392, so that means if I bring here T cos 30 is Rx, so T is 392 cos 30 is equals to Rx. So Rx is 392 cos 30 is 339. So this one is what? 339 Newton. Okay, now we want to find is Ry. Okay, how do we find Ry? We substitute inside here. Ry is equals to W. W is 20 times 9.81 minus T is 392 sin 30. So what do we get? Okay, 20 times 9.81 is 196 minus 392 sin 30. What do I get? 196. 196 minus 196 is 0. So Ry is 0. So that shows that this is a smooth wall. Okay, so the value is determine the reaction on the beam by the wall. That means the actual R is in this direction. The actual R is in this direction, which is 339. Okay, all right, that's it.